Okay, good afternoon, YouTubers. Here we are to discuss a little bit about how to create a lookup table that we can interpolate. For example, I always will know the x value in one point or another, but then what is the corresponding y value? Like, for example, if I have a number that is less than 1023, but above 980, somewhere here, like 990, then we know that the number should be between 231 and 210, basically, and we want the Arduino to calculate that because the data, the X data that's shown here, it can be read. For example, if I go back here to my Arduino, here's an Arduino in Tinkercad, and in this simulation you might have a sensor here, and that is producing, and you are reading of the sensor measure a physical property, something is changing on it, the voltage is changing, and therefore you are reading that analog signal, which is a voltage between 0 and 5, and you convert that to, or the Arduino convert that to ADC, a value, a number that typically is between 0 and 1023. So you end up having this kind of table, but you are measuring actually the physical unit as well. Like this y here could be like temperature, could be anything else, but you are measuring something, and this y basically is what I call here, it has engineering units on it, whatever engineering unit or from the physical property you are measuring, right? So engineering, I said, units. And on the other side, the X is just the ADC, which will be the analog to digital converter, and that's it. So here we are. I have produced these data shown here, and I have a table between X and Y of about 21 points. So let's say that you did an experiment and you measure, you change the physical properties. This 231, it would read the 1023 shown here, or this 210 will read the 980, and this 187 in the Arduino will read 930, and so forth. So you create this table. Now, if you plot X versus Y, X, this is the X, the ADC is in the X axis, and this engineering unit is in the Y axis, then you end up with a curve like this. Two things you can do. Can I have a curve, or can I produce a curve, correlate all these points within a single curve? So that will be good enough that whatever ADC I have here, I can have the corresponding Y. The answer is maybe. Maybe yes, maybe it's not that great. So like, for example, let's try on this one. Let's say that I want to start to do a correlation, add a trend line. Now, as shown there, let me move this. As shown there, is trying to make a correlation with a straight line. Not good enough. I mean, it's awful, but actually, let me fix more on this. Let me format trend line, and let me add the, in this case will be the display and the R value. Extremely ugly. 0.89, that means it's definitely, there's something better than that, than a straight line. You can see it right here. It will not correlate at all. Pretty nothing. It's very bad. So we're gonna change that. Let's say that we change that line, and we're gonna add another one. Let's see. Let's try a better one. Add another trend line, and let's try exponential. Exponential looks maybe better. I can see some better tendency right there. Let's put it here somewhere so that doesn't. Here is exponential. So the exponential is 0.99, but something told me that there must be something better yet, because I want to see here 0.999, but this is not bad, 0.99, but I can see that some of the points are not right at the center, which is telling me that maybe I'm not gonna have a good result in some of the points, but close. I mean, it's not bad. I might try that to check on this. So that's basically the X value here is coming from here. That would be the ADC, and the Y here is the final, the engineering unit, which is not bad. But I'm looking for something better. A curve like that, it just, I can imagine. Let's check again the point here. stop on the point, and see if I can pick the point. There we go. Pick the points and add a trend line again. That would be the third one. How about a polynomial? Now that polynomial, let's add here, display this and this. Clearly it's telling me, let's put this over here, definitely of order of 2, I got 0.9999. No bad. That's a lot better than this one. How about if I go back again to that one? Let's see if I can pick it from here. It's gonna be hard. Let's see if I can format trend line, and it's order 2. How about if I set order 3? R is 1. Perfect. That equation will definitely fit all my point perfect. From the lowest one, let's see, let's get out of here. We're gonna keep that, so we're gonna get out of here. So it can fit, this equation here fit my point from the 1023 down to whatever I have here, 30, and it will produce this, the Y curve, perfect. So I only have actually one zone, one equation fit all my point on the ADC, and that looks great, and that's perfect. Well, I did a little trick on this, and this data shown here actually is not an actual experiment. It's more like a testing of a concept. I did put here, you can see the equation that is behind on the y-axis is just this equation. It's this equation, 1 times 10 to the minus 7, so that's precisely what is here. So it's not surprised that when the correlation between the x and y end up being this equation, because originally that's what I put in place. That was the equation that I put in place. That's what is here, plus the 20 here. So it's okay. I did a little bit deceiving here on what I was doing, but in reality, you will find that it's very hard to correlate all the points through all the data, through all the range from 0 to 1023. And that's where lookup table are kind of convenience to have a lookup table, because instead of dividing all these per zone, sometimes you have to take only 4 points here and then another 4 points here, and you are creating small lines, and just to try to correlate all the points with many of these type of equation or sort of, that's kind of hard. I really like lookup table, and that's basically what we're gonna do now. To do lookup table, somehow, and this is the hard part, you have to pass all this information, all this table from here to here, all the point. If they are coming from an experiment, perfect. But that's basically what you have to put this into the Arduino. So the Arduino will use this table to get your interpolation going, because that's basically what it is. A lookup table is to be used as the tool for interpolation. Like for example, as I said, for a value that is between 930 and 880 here, and you are looking for something here in between. That in between, you need to interpolate here. So, and that's where this lookup table will come out handy. The problem is, I create this column, the X and Y column, but when we go to Arduino, and we're gonna go to Arduino now, let's go to Arduino so you see what I'm doing. I put the code here already, so you have a look at it very quickly of how the code works. Again, the first thing that we have in the code is called the index. The index is very important because it will tell me where in here, what is the range that I'm looking at. We're going to talk more about that. The Y interpolation here is just to save the final value, the interpolated value within the small table, the point that you pick. And here's an example. Let's run this, like for example, the 580. What's going to happen with the 580? What this code will do, it will locate what is the number above and below the 580, and this number is on the X side, right? That's the ADC. 0 is just because probably it's going to be read from here, from that analog. The 580, you go down here, 580 is right here, that number. So it's not fair to look for 580 because 580 is already here. Let's look into something that is between 580 and 530, like 535. Then right here, 535. I'm going to write 535. And so this code should prepare me a table and the result. Let's do that. Let's run this, and here you will see what's going to happen. On the X side, I have the 530. 530 is the lowest. 535 is the value that I'm interested to look for the Y, in this case the engineering unit, and the maximum value on the interpolation will be the 580 because that's the 535 is within this region. So basically within that region, then you need to look on the Y side. Let's see what we have in the Y side for that value. It's kind of hard to read here because you can see that the number end up somewhere here. They don't align properly, so it's very hard, but it's telling me that it's between 63. You look for that 63.03, that's this value, and the highest value is the 73.21. So it's picking the Y value, the interpolated value is between this one and this one. And how you set up this lookup table? First of all, you can see that this is in the horizontal. It's not like in Excel. So there's something here that, and guess what? I don't put any number. I didn't stop to write all these decimal places as you see here. That would be crazy. You don't want to do that at all. But that's one thing that we need to deal with. The next things that you have to do is like, let's see, what else in the code? So here's the number that I'm interested. This number can come from the analog here, or like I just, I'm testing the code, so I put the number there. You can put any number, and that number has to be between 1023 as a maximum, eventually to the minimum, which is 30. It's not 0. 0 will exceed the table, and that will create a problem. That number doesn't exist. There's no number below the 30, so that would be the minimum that you can have is 30. All right, if I put 30 on my code, let's say here 30. Stop the simulation so we know what's going on. 30 here. Stop. Gonna write 0 here. Oh, sorry, 30, and clear the whatever is the content and run it again. You can see that it repeats the 30 because that's the minimum value. The 30, you are right at the border. 30 is 2010, 30 is 2010 because it's interpolating that value. Obviously, it's going to be 2010 as shown here. And the highest value after the 30 is the 80. We can go back here and see for that one ourselves. The 30 and the higher value is 80. That's what's shown here. So no interpolation required, just give you the actual number, whatever it is. All right, so how this code do that? Well, basically, I put this code, everything is within the voice setup because I'm running this one shot, only on one shot, because I'm only testing the code. This code needs to be passed, all that code needs to be passed up to here, with inside the loop, because you are continuously reading this analog, and you want the interpolation to be carried on. But for this only one shot deal, I put that on the voice setup. I obviously starting the serial monitor with the serial begin here, and the speed, the baud rate 9600. I set the index to 0, initialize it. This is the initialized value, but then I'm using the for instruction. The for is a loop instruction. Remember, within the Arduino, you have also loops like this void loop that is run forever, but this one in particular only runs between 0 and 20, because this is the way to set the for. The for, open a parenthesis, the variable that you're going to be running, in this case, what I call the index, I call it I, integer I equals 0, and that means that I'm starting this I value at 0, and then semicolon, I has to be less than 20, and this is important. Remember, I have 21 elements within the array, because this definition here of X and Y, notice that is X is the name of the array, and it has 21 elements. Y is obviously the engineering unit. It also have the 21 elements on it, and these variables defined as float because there's as you can see, there's decimal places here. On the other hand, this part here, the number doesn't have decimal because this comes from the ADC, which doesn't have any decimals at all. So now, how to address each element inside the array? Then you have to call them out. How you call them out? You need to run an index, and that's what I'm doing here. That's precisely what this will do. This run the index. Now, how this will go? Well, one thing that tends to confuse people is that the index will start from 0. So that's why you see, you don't see the 21 here, but you start in 0. So by starting in 0, you have 20 plus this 0, that's the 21. And you will go one by one. This last is the step, the increasing. How I'm gonna run this for? It's gonna start from 0, it's gonna increase one by one, and whatever is between this bracket and this last bracket, between this bracket and this bracket is part of the 4. That's what I'm saying. What happened with this bracket and this bracket? Well, these two brackets are for the if that is here, and we're going to check on that. So, for example, during the first run of this 4, the I is going to initialize to 0, and here is a question: if this value of the ADC 0, and where's the ADC 0? Whatever value is 30, for example, here. Oh, let's change it to a more meaningful value, like A50. Let's put A50. I put A50, and what's going to happen is that the A50 will be checked against the XI, but XI is 0, so it's going to be checked against X0. And what is X0? Well, X0 is the first element here. It's 1023. So that 1023, so what's the question? Is value, in this case ADC, which is A50, less than 1023? Yes. So that index will be whatever index you have right now. If it's 0, I mean 0 coming from here, then this index is 0. So that's 0. So we go back, this is done, and we go back to the 4. Now the 4 is increased by 1. So it's again the A50 check against the X1 now, because 0 was already checked, X1. But guess what is X1? X1 is 980. See? So the A50 less than 980, that's true. So this if will force to get inside here. So the index will be actualized with a new value, which is not 0, is 1. So now it's 1. This is done, and it goes to this bracket, so it returns to the 4. So now we go in 2. And again, you check here. Is the A50 less than whatever value is here at that point? Right? So let me do a comment here. So what I'm saying is A50 at that particular moment is less than XI, but XI at this point is when I is 2. All right? So when XI is 2, remember this is 0, 1, 2. That's 930. 930. 930. Is A50 less than 930? Yes. So it gets here. So now the index, that variable is updated, and you end up saying that index at that point, I should put like this, index will have a value of 2. So this is done, and then it go back here again with the 4, and the 4 now the I is at that point is 3. So when it's 3, what is 3? That's 0, 1, 2, 3. That's A80. So the question is A50 less than A80? And the answer is yes. So you get here again, because if this is true, whatever is in this bracket will be done. So that index will be updated, and you have 3 here. See? Now, go to this bracket again. That bracket, this last bracket belongs to the 4, so it returned back, and the 4 is increased, and that increases the value here on the I is at this point is 4. So 4, what's happening in 4? Well, when the index is 4, you have 0, 1, 2, 3, 4. So 4 is A30. So now we have an issue here. because that's A30. Now, A50 less than A30, no. So the index will stay with 3. And that's very important because index of 3, it means that I identify the X value that is higher than the A50. The lowest will be the index value plus 1. If you add another value to the 3, that will be a 4. And that's actually what this equation is doing. This equation is doing the interpolation based on that concept. That's why you see here index plus 1. Index plus 1 is looking for that particular value on the Y array, because there's two arrays here, one X array and there's the Y array. The Y array is the engineering unit, and the X array, this one here, like X here, is looking into the ADC. And if you check what's the definition of this equation, is interpolation. What you have here is actually the true equation for doing interpolation. All right. So what is that? What is here? What's the the extra code? It's just to print things nicely. Like for example, the title X \T that means a tab, and the Y. So you got the title here, and then serial print X index plus 1. Index plus 1, that means that whatever was the index, in this case, let's say 3 plus 1, that would be 4. So the first value that it will print is the A30. So let's run this so that we can update this piece here and looks this better. So let's run all this, start simulation, and let's stop there. So you see the X, the index is 3, but 3 plus 1, that he you the A30. But the A30 corresponds to the same on the Y array, which is index plus 1. 3, that's 4. So the final content of that serial print is 4 for the Y. And now what's this is A50 come from? Well, that's actually the ADC 0 that we are looking, and this is the interpolated value. Where the A80 come from? That's from the index directly. So this is the table. I'm showing you. You don't need to show this table. I'm only showing the table here just for the ensuring that you understand what's happening and how the interpolation is going. I mean, it's very straightforward that the interpolation done here is basically this value, the A50 minus A30, divided by the A80 over A30 equal this value. You don't know this value, so you can call this Y interpolation. So this is going to be Y interpolation minus 146.15. Divide all that between 165 less than 146, and then put everything in terms of this Y value or the Y interpolation here, and end up being 153.96. You can certainly do that by hand and double check that. So that's basically how this will work. But now that you understand a little bit more about how this code is working, the only question is how you can put all those numbers there without touching anything, without writing it yourself. Can you imagine you putting all these decimal places there? That's crazy. You can't do that. You shouldn't do that. So let me dedicate a few seconds, a few minutes for my, on this video to get this done. So let's do that. First of all, let's go to Excel. Here is Excel. How I get that data, which is basically here, is this data is in column, but I need that data in a row. So let's do something here. Let's put it here. I'm gonna use an instruction that I learned a few years ago, which is called, I have a similar problem that my data was in a column base, but I need it in a row base. So I learned something called transpose. Very interesting when you work with matrix and things like that. Transpose of what? Well, it's gonna be from here, shift down, close the parenthesis, go back to where you put that, and hit enter. So basically whatever was here in a column base was transformed into a row base, which is great. Certainly we will do the same with the other one. So equal transpose, and from here, control shift down, close the parenthesis, go here and finish the parentheses, hit enter, and there you have it. You have the data. Now, how this data, I have to say that in Excel, this column is separated against this column by a tab. I mean, you know, like you're using an actual tab to separate numbers. So I cannot, the way it is, it will not work for me, because I need to massage a little bit this information so that it get properly set, so that it looks more, it has to look more like this. See, it's separated by comma. The element must separate by comma, as shown here. You see, each one of them. And how I know? How I know that I have 21 points? Well, basically, just because that's what you know, the number of points you set here, 21 points. So, not that I have to count them, but you know. All right. So here we are. We have a problem. We have the data row wise, but it is separated by tab, not actually by comma. So let's copy the whole thing. So I copy that. Let's see, copy. And now we go, and another trick of these, go to a file called like Notepad. Notepad will do it. Notepad. Let's see, Notepad. Open a new Notepad, and I'm right there. Now, I did a copy of the row in Excel, so let's paste here. I got all the numbers there. And one thing that Notepad will do, will put all those numbers. You can have a lot of numbers, and they will go right like in a single row. And but there's an issue here. I need commas. I don't want this to be separated by spaces or a tab or anything like that. So this is the nice trick that you can do in my friend here Notepad. Let's say I don't know what is happening between these two numbers, but I know that Notepad knows, and that's for me is good enough. So like for example, when I step here and drag the mouse until I get everything on blue, just hit Control Copy, Control C, and Control C is copying a special character that is there, that is separating those two numbers. And what is happening is that that same character is separating everybody. So what we're gonna do, we're gonna go to Edit, and we're gonna go to some here says Replace. Now in Replace, I'm gonna put there Control V as Victor, and here I'm gonna put a comma or whatever symbol you need to put in to be replaced. In our case, since we are using the array in Arduino, it needs to be separated by comma. So now let's see if this works. Find next. Okay, I'm right at the end. Let me go back to the beginning, see if I can go to let's see here. Let's see, find next. There we go. Find next. You see how we find it? Now I can replace it. You see, perfect. I put a comma between this number and this number. I can do one by one if I want to, you know, bother myself and be sure that everything's done right. But how about we replace all? When you know that it's working, I don't see why it cannot work to the last one. So replace all, and you are done. Basically, we are out of here. We got a nice, our array separated by comma, and it's perfect. So you copy the whole thing, copy, and now you go into your Arduino, and let's say that I haven't. Let me stop simulation. Let's say that I'm going to put that here, and that. So paste it, and there you have it. Now let's put some format into this. Let's call this a different variable. That's going to be integer. We're going to call it x2, just to call it different, equal, then open a bracket, and then go to the end and close it with a bracket and the semicolon, and you're ready. That you need to define here then that x2 has, now notice the different bracket that I'm using, a square bracket, and that's, you put the number of elements that you're going to have. That's x2 has that variable, the name is of that variable is x2 and has 21 elements, and here is the definition of the 21 elements. So we're going to do the same for the other column. We go here And this is the harder one, because this is the one that had all the decimal places and everything. So you copy this one. See, you copy that, copy. Well, actually, let's put it together. Here we go. So we copy that, control copy, and now we go back to, in this case, to Arduino here, and that was integer. This is the only, you have to keep in mind that you want all those integers, so definitely it has to be a float variable. We call it y2, call it different, 21 spaces or 21 elements equal, open a bracket, paste, and you can see all the oops, I forgot to do something on this one. You remember, you can come here and start to put the comma yourself, but you know what, I refuse to do that. So we're going to take all that out, delete, and what we're going to do is we're going to do the treatment here. So we're going to go back to to Notepad, paste it, and now what we're going to do is the comma treatment. Remember, this go to the end, and then this number here is after a tab. So what we're going to do is the same. We're going to copy this, like for example, step here with your mouse, and or anywhere that it allows it. So copy, and now go back again to edit, replace, and I think that is there from the last time, but let's say that it's starting from scratch. So put it there. It doesn't seem like there's nothing there, but there is something. There's a tab there, and then we're going to replace it with a comma. So we said find next. You see how we find the next one. So you can start to replace, see where they put the comma. So replace, 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 or replace all, and we're done. We are out of here, and that's it. So we got everybody separated by commas, and what we're going to do is copy the whole thing again to the last one. Ensure that I copy, use the copy, where we go. Ooh, that's the last one. So we copy that, control copy, and we go back then to Arduino, and finally open the bracket here, paste, and go to the end. See, which is the same one as above. Close that bracket and semicolon, and I think we are done. So we got also, again, I mean, it's the same definition. I'm just telling you how to transfer all those numbers that you created from in Excel to Arduino in an array. So remember, x2 is not one element. x2 is 21 elements, and each one of these elements has an index. So this start with 0, 1. So if I have 21 here, basically the index will run from 0 to 20, right? So that's the main point. And I'm not doing anything with this x2, but this could be another data coming from another analog. So you can have up to 1, 2, 3, 4, 5, 6 arrays here, XY talking about, right? XY type of array with different data, because you have different analog and you want to provide engineering unit, or you are reading six sensor of temperatures with their own calibration. So you will have an array like this one, X and Y, for that sensor. So the idea is that, and this is much better and easier than adding like 3 or 4 or 5 zone, because on this one is straightforward, because when I build this side of the XY, this side is an equation there. So I can certainly put the equation, because it goes through all the point and it's a perfect match from the first point to the last one. And the R here is 1, indicating that this is a perfect match. So whatever number you need in the middle here, you can easily get it. But that's not the way life works. No, you will have to, when you put real data here, you will work for, based on zone, different zone. A zone from 0 to 200, another zone from 200 to 400, because these points are not following in a given line, so that makes life harder. But again, I'm just only showing you how can you use lookup table? You start with an XY from an experiment, and then you transfer that data into your array here in whatever you're using, in this case for this Arduino, that, and the array has 21 elements on it, and then you use, like I'm showing here, you use here the you run the index using the instruction for, and whatever is in between this bracket here and the last and this bracket here, that is going to be done 21 times, from 0 to 20, one by one, checking where you are until you find the index for your lookup table. When you find that index, then that index will help you so that you can get this equation going. And this is it's a simple interpolation equation. All right, and here is all these can be take it out because it's only to print the table. Perhaps the only thing that you care is the 850 here and the 153.96, because that's actually what you're looking. If your ADC is 850 coming from your analog sensor, then that will end up being 153.96 based on the in this case on the interpolation. I'm not using the cubic equation. In fact, to finish this, I can put the in this case, let's bring from Excel that equation there. See that equation there? I can use it the way it is right now, and I'm gonna copy the equation. Copy, Control copy, and then go back to my Arduino here, and in my Arduino I'm gonna put that equation here, and I'm gonna call that y calculated, because it's calculated, and we're gonna put that there. And now every time that I set b2 to the cube here, basically it's just the value that you're looking. In this case is ADC 0 times, I'm not using the power function, I'm just gonna go ADC 0 times ADC 0, because it's ADC 0 to the cube, and this is squared, so I go times ADC 0 times ADC 0, and this B2 is time ADC 0 plus 20, put a semicolon at the end, and now I have this new variable that need to be defined, y calculated. So let's go back here and put a float, and that's going to be y calculated. So what I'm doing is I will have now a way to compare how good is my interpolation versus how good the one coming from the y calculated, right? Which is from an equation. Again, this is ADC to the cube, ADC square, and ADC plus the final 20. Let's put 20.0, so everything's on a float here. That looks better. All right, so what I need to do now is I print the title here. This is the X and Y title. I print the index plus 1 here in the first, and the 850 and the 153 are right there. Let's see what they are. ADC 0 and the Y integer. And now here I'm gonna print nearby here. So let's open here one thing and let's write the serial print, and let's say ln, but now actually no, not ln. Let's write a tab. I'm gonna put a tab here, so it's gonna be a tab \t, and then close that. And now go back and do a serial print, but this one will have the ln, and now we're going to print the actual variable that is y calculated, and we close, and that's it. So basically you're going to see the 850, this value, and another value here, which is for to see how good is the interpolation versus the actual curve, or the actual result produced from this equation here, which comes from a correlation between the x and y. access. So I think that we are good enough here. Let's see how this goes. Start simulation. Actually, I should have cleared the whole thing. There's missing something here. ADC was not declaring the scope. Probably I put confuse one variable with another. Let's see where that happened. ADC. Here is a problem. It's ADC 0. Here I put an O. It says 0. Let's see if I repeat that problem someplace else. Nope, looks good. So close. We open the serial monitor. We clear again, and we start. Let's see if I get the whole thing going. There we go. So it's 146.15 and 153.96 and 153.75. No bad. No bad. All right, so let's do another one. Clear, and let's do again check. Instead of A50, let's say stop simulation. Let's move to A30 or A40. Actually 734. So start simulation. 133.55, 113.55, 113.55.49. Not bad. And that's the 734 between this guy and the 780. So that's basically how you will go into do this. All right. As I always said, have fun. Have a great day. Bye.